So now we know how to factor polynomials, we can proceed to solve homogeneous equations with constant coefficients. When we solve the characteristic equation, there's going to be three cases. The first case, which is the easiest case, is when the characteristic equation has all distinct real roots. So suppose the real roots are distinct, let's call them R1, R2, all the way to Rn. Then the general solution is a linear combination of e to the R1x, e to the R2x, and all the way to e to the Rnx. So it's a linear combination of these exponential functions. So let's do an example here. So let's take the differential equation, the third derivative of y, plus 3 times y double prime minus 10 times y prime equal to 0. So the characteristic equation is r cubed plus 3r squared minus 10r, nothing here, equal to 0. This thing factors easily. R factors out, so it's r times r squared plus 3r minus 10 equal to 0, which further factors into r plus 5 and r minus 2. So the roots are 0, negative 5, and 2, which are distinct real roots. So the general solution is of the form y equals to c1 times e to the 0x plus c2 times e to the negative 5x plus c3 times e to the 2x. E to the 0x is just 1, so it's equal to c1 plus c2 times e to the negative 5x plus c3 times e to the 2x. Alright, so let's do a different example. Let's consider the differential equation y, the third derivative, minus y prime equal to 0. So the characteristic equation is r cubed minus r equal to 0, which factors into r times r squared minus 1 equal to 0. R squared minus 1 is r minus 1, r plus 1. So the roots are 0, 1, and minus 1. So the general solution is of the form y equal to c1 times e to the 0x plus c2 times e to the 1x plus c3 times e to the negative 1 times x. Again, e to the 0x is 1. So the general solutions of the form y equal to c1 plus c2 times e to the x plus c3 times e to the negative x. But now suppose we have initial conditions. So it's a third order differential equation, so we need 3 initial conditions. So let's suppose y of 0 is equal to 1, y prime of 0 is equal to 0, y double prime of 0 is equal to negative 1. Then this translates into a linear system of equations. So we need to first find out what y prime and y double prime is. So y is equal to c1 plus c2 e to the x plus c3 e to the negative x. So y prime is equal to, the constant goes away, so c2 e to the x minus c3 e to the negative x. And y double prime is c2 e to the x plus c3 e to the negative x. Alright, so these initial conditions turns into systems of linear equations. So we get c1 plus c2 plus c3 equal to 1, and c2 minus c3 equal to 0, and c2 plus c3 equal to negative 1. Alright, so these two together tells you that if you add them together, you get 2c2 equal to negative 1, which tells you c2 is minus 1/2. And this tells you c3 is also negative 1/2. And the two together tells you that c1 is c2. Alright, So the particular solution is y equals to 2 plus minus 2 minus 1/2 e to the x minus 1/2 e to the negative x. Right.